Our third speaker for tonight, presenting Omid Hajihassani, a machine learning inclined analyst at Isaac, as well as a master's graduate at the University of Alberta. As the machine learning inclined analyst at Isaac, Omid is passionate about high performance computing programming and how to apply machine learning to business problems. Up next, security and privacy. Please welcome Omid.
So thank you everyone and thank you Nora Alberta Tech for having me on this presentation today. And so my name is Omid Hajihassani, as mentioned. I am a machine learning and client analyst at Isaac. So Isaac is a local cloud provider located at the EC department of the U of A, and we have a wide range of GPUs and compute power and serve SMEs and also research and academic clients. So the talk today is going to be about security and privacy in AI. The general theme would be the data science and AI journey for SMEs and any clients that want to use AI-enabled technologies in their day-to-day products. And also, we are going to give some information and much needed knowledge of data biases and data privacy best practices, and also the problems that might arise in these kind of applications, and applying AI to your to better your product line with your startups or any other solution that you want to build with AI. So the agenda for today would be that first we are going to talk about the opportunities for AI use in everyday lives. We are going to see two examples of SMEs in local Alberta and Canada that are using, and for SMEs, I mean small to medium-sized enterprises and also startups that use AI in their product line. Then we are going to look at a data hierarchy of needs pyramid and look at some assumptions that we make with privacy in AI applications and adoption. We are going to move on to challenges with data collection and storage, then the data transformation and pre-processing for the use of AI models, and training of ML models, which is the capstone of the pyramid of needs that we're going to see. And at the end, we are going to have some key takeaways, if you may. So one important thing that I noticed is that in most AI courses in university, algorithmic view is given much more weight. So when you go to the course, you study about algorithms, you study about the deep neural network, the training and everything else, but the data is ready. So you go and train your data on MNIST, or you go and train your data on any other data set by downloading it. And much less attention is given to how you need some proper data collection procedures to have your AI and machine learning models best perform in a real world scenario. So I'm gonna go to the first examples, which is use of AI in agriculture. Precision AI is a Canadian-based startup and also SME. So they noticed that if you want to clean out the weed in a field, the usual approach is that you have your combiner, or you have your tools, and you just spray chemicals and herbicides on the field, and like you carpet spray the whole field just to kill 10% of the field, which might be weed. Precision AI actually uses drones with image processing and neural networks and DNNs to surgically identify weed and then apply the needed amount of herbicides to it. They noticed that 85%, they noticed an 85% reduction in herbicide use, which translates to safer food and less herbicides and essentially hazardous chemicals in our food chain. Another company, as an example, in AI would be Clinisys. Clinisys is actually using AI in EMR, which is electronic medical records. What they notice is that 50% of their product line has been benefiting from AI compared to not using AI, and they noticed that there is this requirement for AI use in the medical ecosystem and also infrastructure that can provide such applications. So let's get to the data science hierarchy of needs. So in this figure, which we have a perfect illustration of the different steps required for a journey from the beginning, which is the collection of the data, and then to the end, which is the capstone of the project, which might be the training of the deep learning models. One important thing to notice is that these steps aren't sequential. These might be iterative and cyclical. So you might be training your AI model by having your data collection done already, but noticing that, okay, we are missing a certain attribute, or we need this data with a different fidelity or resolution or another source of data. So you might want to perform some data fusion and then combine data from multiple facets. And then you go to step one, which is data collection. So the first step would be to collect the data. Of course, there are privacy challenges in the data collection process. So you have to make sure that your sensors and the IoT devices that you're using and the communication technology that you're using to collect data from the field to your own, for example, servers are safe and secure so you don't leak the data. While the data and the instrumentation is ready and in the field and is being collected, we need a solution for moving and storing the data. Sometimes, and in most of the cases, the moving and storage of the data and the data collection process are combined through pipelines that talk to the IoT and IoT sensors and devices in the field, and then connect to the storage, which might be any sort of a structured or unstructured data storage scheme that you might be running on the backend. And after we have the data collected, there is the step for cleaning and anomaly detection, and also understanding the biases involved in the data. There are always biases in the data. There is the survivorship bias that we might encounter in our data collection process. So we have to be aware of them while we are cleaning the data and while we are evaluating the data for our process of the next stages, which would be learning and optimizing, labeling the data, and then building the AI model that we want. So some privacy concerns in general include the assumptions that we make. So as an end user of, for example, Apple products, I assume that Siri is safe, meaning that I know Apple might be collecting my data, but I trust Apple with my voice data. You might ask why, but that's the only way that I can get to use Siri. So as users, we might be perhaps comfortable with some data privacy assumptions and not really comfortable with others. We might not want our baby cam in our bedroom, which monitors the baby movements, or actually you can listen to the baby crying, talk to a server, because I don't want the picture of my baby on a, for example, third-party application or server. So with different products come different assumptions and comfortability. As companies, we also have to be cognizant about the assumptions that we make. There are APIs out there. For example, there are chatbots that are ready-made. Do I want to use this ready-made chatbot that Google has for my customers in medical cases? Because who knows, based on agreements or any sort of collaborative or, for example, a medical agreement, perhaps we are limited to share our data with a third party or our users' data, which might be medical data, with like Google Cloud, or due to Patriot Act or all these other acts, we might be limited to do so. So sometimes as companies and startups, we might be limited in what we can use based on what agreements and what requirements we have in order to safeguard user data. So if you are renting out cloud, we have to essentially be comfortable with the standards that the cloud provides. Sometimes you are not allowed to use third-party cloud providers, and you have to keep the data local, perhaps to Canada or even the hospital that the data was collected in. So let's get to the data collection process. So data, this is a perhaps a commonsensical term. Data is the new gold rush, meaning that information is key. So here we have a projected view of how much data is going to be generated by year 2025 based on different regions of the world. So by year 2025, it says that perhaps China is going to have roughly about 50 zettabytes of data generated in that year. And then rest of the world, for example, US, Asia, Pacific, Japan, excluding China. So the projection is that data generation is growing, and there is much inside this data locked in it, and with representations and key insight that it can provide for any application. For fintech, for medical cases, you might have new drug discoveries that you can use from old medical data that is generated and collected. So data is essentially going to be generated more and more. And the data that is generated is going to be multifaceted. So at the center of this diagram, we have the data collected from a universe of sources. We have data collected from our business partnerships, financial transactions, multimedia. So you might be using Instagram as a source of data for the product that you want to sell or improve. Mobile apps, operation systems, and anything else that the user interacts with and leaves breadcrumbs even of the data and their daily activity in is considered a source of data. It is multi-source and multifaceted, and with a different perhaps nature to each data point that we collect. Social media data might be graphical. Operational system data or mobile app data might be, so you, for example, your gyroscope data or IMU units collect time series data. So all these data being collected are different in nature. So if you want to mix and match these data sources, you have to use novel techniques. The challenges with the data collection process can be included in the 5V scheme discussed in the big data. One is volume. So the size of the data collected is going to grow as we saw actually. The velocity, the variety, as we saw with the multiple sources of the data, the veracity, the correctness, and the accuracy of the data that is collected, and the value. So value can be considered how much importance does this data point carry with itself, or the cost that you have to pay to collect the data. So all are included in the value of the data. So there are multiple challenges, and as well other challenges like storage, as we didn't discuss with the 5V scheme, and privacy. So as we saw and as we mentioned with the privacy assumptions, there must be sharing agreements. For example, if you're going to look at EMR data, you might have to go and talk to, and you actually have to talk to Alberta Health Services if you want to use medical information. If you want to use medical imagery, you have to make sure that no perhaps privacy intrusive information is carried over if you want to use it for training of your models. So you have to make firm adjustments to your privacy preserving guarantees that you make to AHS. Or for example, if you want to go look at another example is Johnson & Johnson. So Johnson & Johnson, J&J is a big company. They are having COVID vaccines, multiple drugs that they produce, and it's a big pharmaceutical company. And if you want to use their data, you have to agree with their terms, or they don't share the data with you. So you might be limited in the product that you can provide and essentially how you can provide it. There is reality in the field with the data collection. If you have to go into the rural area, make sure that you have a good service, because sometimes there is no internet and phone service. So with Starlink, with these new technologies that use satellite for internet access, then if you have a field, if you have uh, any sort of farm, for example, we saw with precision AI, they have to collect images and videos. So that's a challenge of its own. So you have to think about this. And then the cost of expertise. I have to hire someone who knows, for example, different kinds of tree sap in order to build a product to identify tree sap. So, and that's costly. So, and they need proper training to understand AI. So these are challenges that we might encounter in the first step that we want to adopt AI in our solutions. Let's look at perhaps an example of privacy concerns in data collection and storage. So say you want to build a smart home, a smart house solution, occupancy detection, any other solution that you want to build into your HVAC system for better or less carbon footprint in your energy usage. If the data is leaked through the application, and perhaps through cross-checking with other data sets, or through the leakage of information, if you might actually collect the address or the IP address of the smart home device that you, and save it in the data set, and then it is leaked, it can be reversed back to the address of the people, or the residential address of the house and the owner of that house. So essentially, if I'm a burglar or robber, actually I can understand the pattern that they use their HVAC system, and then I can understand when they leave the house. So I can plan a break-in for my safety. So these are important points in the privacy, and then safeguarding the privacy of users, and you have to be cognizant of that. If the data must be collected, there are techniques like differential privacy, k-anonymization, and any other algorithmic or systemic approach to safeguard the privacy of the users. If models must be updated on the user end, and you have to send out the model, you might be using federated learning for better, because then you are doing, federated learning is actually a distributed learning scheme, which doesn't need for centralized data to be collected. So it is a way to handle the privacy concern. So let's get into the data collection. So the collected raw data isn't ready for use in your AI algorithm and for your training. The reasons might be that it might be noisy, it might have missing values. So you have to set out to correct that. So you can apply image pre-processing, noise reductions, and sound noise reduction and voice. I don't know why I said voice and sound, but bear with me. And sorting and ordering and filling out missing values. So if you're collecting from the field, your sensors might actually pick up random readings which aren't correct necessarily or representative of the real world. So you have to be clear about that, and you have to perform some anomaly detection in order to root those misrepresented data entries out of the data set for the proper training. There is this term in machine learning, as I have the emojis up, that's supposed to mean garbage. So garbage in and garbage out. So even if you have the best AI model, you have the best training scheme, the best hyperparameters out there, and the highest accuracy. If your data is essentially not representative of the real world, so you're making your decisions and your essentially the output of your model is based on something wrong. So you are having a deviation in the distribution compared to the real world. So you have to be essentially really you have to be really careful about the accuracy of the data. So if done improperly, and if you leave biases in the data, perhaps in most cases, this is not a mission critical system that you have to build. If you're building a drone that sprays herbicides on plants, then you might essentially spray herbicide on an actual plant rather than a weed, and it's not the end of the world. But in medical cases, if you're making life and death decisions, or in perhaps even self-driving cars, uh, the most minute error will lead to catastrophic outcome. So it is important to weed out the bias. In socioeconomic decision making, with historical data, there would be always biases because politicians and the decision makers aren't always motivated to make decisions based on the best interest of the people. For example, the problem of gentrification. But if you train your AI model on those information from the history or the path or the past, it is going to learn that and make the same judgment calls which are biased. So the actual point here is that you need to do a proper job in aggregating data, rooting out a bias, and also making sure that your data is representative of the real world. So one of the biases that can essentially find its way and probably will find its way into your application is a survivorship bias. So survivorship bias is a logical error in having data and making decisions on a data which actually passed through an selection process. So if you have any sort of selection process that prefers some data points, even based on its frequency, so you might have some rare occurrences of some really marginal important data entries that you wouldn't pick up. Or you might go and collect data in the morning, which might affect your sensors. And then based on the temperature, your sensors might be reading something else. So it is important to have the survivorship bias in mind. So one example of that was that in the World War II, essentially, when the fighter bombers came out and returned to the bases, the engineers saw that, okay, these planes that returned were shot in these specific areas. Let's bolster that, let's reinforcement that with, I don't know, Kevlar material. They didn't have Kevlar back then, but with whatever we have, uh, so that we improve the chances for our airplanes not to be shut down. But essentially, the important point is that these were the planes that survived being shot at. So it bolster and improve the parts that weren't essentially shot in these planes that return, so you have a better chance of keeping your planes out of the, no, in the sky and out of the ground. So let's look at building and optimizing the AI model. Essentially, bear with me, this is going towards the end of the presentation. So the capstone of the pyramid that we saw was essentially training of the AI model and having your models being trained on the data. So finding the best model and algorithm is key. So not always, as we know, as I'm sure most of us know, and it is taught in every course, there is not one one size fits all. So there is no universal solution. You have to always improvise and then sometimes compromise. So so after we have the model, we know what we want to do with it, and we have the data clean. We are going to use perhaps CPU only or GPU optimization, or in some cases TPU from any other cloud provider out there, or your on-premise solution to train your models. So it is essentially a process of repeating yourself multiple times with different parameters set for your models, with different configurations for the best accuracy. And you have to try out different parameters, you have to try out different models and techniques to find out the best fitting solution for your own problem that you have. So some models that are out there, so this is not exactly correct. It doesn't mean that statistical models that we have, as I said, are low in complexity, but in essentially in performance requirements of the computer, you can get away with running the Bayes algorithm or any other a statistical approach on your own computer if the if the data set size allows it. But with DNNs or with, for example, with the past presentation RL, essentially you are in need of some capable GPUs, which nowadays come with 80 gigabytes or 100 gigabytes of RAM for proper training of your models. So the different intensity essentially and the complexity differs based on the models and techniques that you want to use. For example, if you want to use time series gated graph-based, so graphical convolutional neural networks are essentially hard for me to understand. So I rank them a very high complexity, but it might be easy for you. So this is from my point of view. And based on your data, you have to use the best essentially solution for yourself. Uh, so some privacy concerns, let's look at some privacy concerns with the AI models. So let's have an example of, for example, an AI model being trained for medical purposes. And you have to retrain the model locally on the user data, on the user's device. So my smartwatch is actually, for example, doing some magical thing with AI to understand my health. And Apple needs to update that model and train it. Am I done with the time? Okay, okay. So because I have a couple more slides. So sorry for that. Okay, so one of the attack surfaces in this scenario would be the model inversion attack, which the attacker, by having access to the model itself, can regenerate the input data and the original data set that this model was trained on. So in medical terms, it means that the attacker, with having access to your model, would eventually have access to the original user data that you used it to train with. So membership inference attack can be also one of these issues that might arise from this problem. And one solution would be to use trusted execution environments, which are systemic approaches. So we saw algorithmic approaches with K anonymization and differential privacy. Systemic approaches would be to use TEEs, which are specific parts of the operating system and essentially the CPU to have safeguards against accessing the registers and the memory of the running application by the other applications. So one thing to make the presentation flashy was for me to use an example from DALL-E 2. So it is more than the question of privacy or security, and in some cases, it is a question of ethics. So imagine, if you will, that we ask the OpenAI's generative model to draw us. So this is from the source. I put it there not to be, so look at the source. That's not mine. So DALL-E, we asked DALL-E to create, for example, IT professionals repairing laptop computers in the style that Van Gogh actually paints with. So the question is, in your opinion, is it ethical, or are we essentially using Van Gogh's painting style without his consent? Or, for example, you might ask ChatGPT to write you a Tom Clancy novel in the Jane Austen writing style. Is that something you want to do, or is it even ethical? So it is important to ask these about your product that you want to put out there to make sure that you are within the boundaries of not being sued. So yeah. So the key takeaways, if you will. So adopting AI in business is a multifaceted challenge and requiring IT and AI skills in different areas and domains. As we saw, if you want to go into the field, you need specific analysts and experts in that field, for example, understanding the plants. So you can get help from Amy, Cybera, Isaac, which are local, essentially organizations to Alberta that provide these services to you. If you go to Milo, if you go to Vector, they can also help you, I think so. So in the ecosystem, if you have a startup that you want to build out and you are in need of AI support, you can go to these companies in the Alberta. So it is important and paramount to study biases in the data and handle privacy and security concerns regarding user data safety and also ethics. And as we saw, the data hierarchy of needs essentially encapsulates the different steps, but it is a problem of its own with it being cyclical and having different caveats to its privacy and the concerns that you have to keep and the assumptions that you have to make. So with that, we end the presentation. I think I went over time. I open the floor to your questions. Thank you. Thank you.
So do you deal with security concerns that aren't directly related to privacy, such as, for example, model poisoning?
So do I, you mean me specifically, or we have to?
Like I'm trying to get a good idea of how this is like I guess treated,
Mhm.
whether this is
Okay.
you need to be concerned about how the data that you have may possibly lead to your model being bad. Maybe an attacker has access to some of the data set your AI models.
Certainly. So we see some CNNs that if you, for example, force in some kind of noise. For example, I saw an example. I don't have the illustration here. There's an example that you pass a picture that to a human eye is essentially a dog, right? So you pass a picture of a dog to the CNN that you have, but you trickle in some random noise, but not random with a certain distribution that based on your understanding from the model will always lead to the model making a wrong decision. So for example, say you have a self-driving car and you wanna show it a picture that is not a pedestrian, but then it is a pedestrian to do any inference essentially uh, thing that you wanna do. I'm not sure, but there are these attacks and the safeguard against them is a hot topic in research. So federated learning has come up in this research, homomorphic encryption essentially. So uh, there are different venues in solving the different attack surfaces that we might have on these black boxes that we call AI models. Essentially, if you train an AI model, you are learning some representations and then mapping those representations for classification tasks and mapping them to any decision that it is making. So you are not sure how it's gonna break. As you mentioned and alluded to, you can have some random noise being added to it to lead it to essentially make that bad decision. And in showing in a CNN that identifies dog from Apple, that's not a problem. But if you have a really mission critical model that needs to make important decisions, if you can do that, it might lead to something really catastrophic even. So it's a valid question, but then in my opinion and with my understanding of the research domain, it's a continued endeavor in order to safeguard these models. Uh, it is quite challenging as in most of the applications, adversarial training is used, and you don't know if your model is becoming immune to another specific model or to a whole area of attack. So meaning that, for example, uh, uh, in my thesis, we worked on human activity data sets. So we wanted to make sure that your smartwatch can identify that you're walking, but it cannot identify your age or your gender or your height and weight. So you don't essentially, they can have it, but why should they? So they only need to the access to the utility of the data. So one of the previous works in the literature actually use adversarial training to make sure that, for example, an autoencoder cleanses the data from those privacy intrusive attributes. But from our research, we understood that the autoencoder is essentially learning to fool that single model, meaning that if you retrain the output with the correct labels, you can train another model that identifies the original privacy intrusive attribute of the data. So it is quite hard to, with these approaches, an AI, which is a black box approach. So any other question? Sorry, I rambled on. Do we have chat questions? Right. When, okay, very good. Thank you.